This is skill 1.7, distance tool number 2, and in this video we're going to be learning about the distance formula and how that can be used to find the distance between 2 points, or in other words, to find the length of a segment. So distance formula, once again, it might be familiar to you if you've seen this before. That is a good thing. It looks like this. It says that the distance between any 2 points can be found by doing x2 minus x1 squared plus y2 minus y1 squared. Now, where in the heck do x1 and y1 and x2 and y2 and all of that stuff come from? Those come from your points. Point A has an x value and a y value. We'll call them x1 and y1. And point B is going to have an x value and a y value. We'll call those x2 and y2. Okay, so you can decide what you like better. If you like the distance formula better, if you like Pythagorean theorem better, they're both tools that can be used to perform the exact same job, to do the same work. So actually, I'm going to use the same 2 examples I used in the 1.6 lesson. We're still going to be finding the distance between point A and B, but this time we're going to use the distance formula instead of the Pythagorean theorem. So I would still connect those points just so you kind of have an idea of what you're doing here. You could kind of get a rough estimate of what the distance might be there. You can't really count boxes, but you can kind of estimate, about how many boxes that might be, just to have an idea before we get started, okay? Now, once we get started, we need to list our points. So A is located at, let's see, over 1 up 2. So 1 comma 2. And remember, we want to label those x1 and y1. And then point B is located left 1, 2, 3, 4, and down 2. So -4, -2, and that's going to be x2, y2. So we're thinking of point A as kind of our first point and point B as our second point, and that's why it's getting the 2's in the subscripts. Okay, at that point, we're going to use that distance formula. And the distance formula says make a really, really big square root sign and do x2 minus x1. So -4 minus 1 and square it. I just took this guy minus this guy. Okay, then I'm going to do the same thing with the y's. -2 minus 2. And square those. Okay, now the really nice thing about Desmos is that you can just punch that whole thing right into the calculator all at once. So I'm going to do that. I'm just going to open up my web browser, go to desmos.com, hit graphing calculator. I'm going to open the keypad, square root button, and then I got to remind myself what it was, -4. And you can just use the minus sign for both of them. It doesn't matter. Square it. Plus, and then what was it? It was -2 minus 2. -2 minus 2. And square that. And there is our answer, 6.40, which is exactly what it was when we used the other tool, the Pythagorean theorem. So we're right on there, 6.40 as our final answer. So let's write it 2 ways. Let's do this. And we're also going to write it like this. The length is 6.04. Okay, now I'm going to bring up one thing really quick right here. I'm not going to be super fussy about it right now in the first unit. Eventually, we're going to start being a little bit more careful about this. But anytime we round, technically we shouldn't be using equal signs. We should be using approximately signs, because it's not exactly 6.04. It's close to 6.04. So in an ideal world, we will start getting used to doing this. Okay, this means approximately. Okay, I don't want to throw too much at you in this very first unit, so I'm not super concerned about it right now, but we'll continue working on that. When we round, we really should be using the squiggly equal sign to tell the world that it's not perfect. We actually rounded in that case. All right. Moving on to example 2, we already know the answer if we remember the notes from 1.6, but let's use that that other distance tool to figure it out, the distance formula. Okay, now the cool thing here is we don't even need the graph. If you want to use a graph, you can, but it's optional because we have everything we need. We don't need to draw a triangle. We can just label these guys x1, y1, x2, y2, and we can substitute all of it directly into that distance formula. So remember, we want to do x2 minus x1. So 3 minus negative 2. That looks kind of weird, but that's what it is. We are subtracting a negative. Square it. Plus negative 1 minus 4. And then square it. All right, and then you can just punch that in to Desmos or really any calculator that is somewhat decent and supposed to be used for a high school student. It will probably work for you. So I'm going to grab Desmos. I'm going to grab a new line. We could really even use the same line. Maybe I'll actually do that. I'll show you. You can just do this. So we had negative, what do we have? Negative 3. Negative 3 minus negative 2. And we can just go over here. And we had, what do we have? Negative 1 minus 4. Oops. Negative 1 minus 4. That should have been a positive 3, shouldn't it? Yes, 3 minus negative 2. All right. I shouldn't have done it that way, but that's okay. We got there. So final answer should be approximately 7.07. Or AB is approximately 7.07. That's about the best way that we could write that answer. Alrighty, so in summary here, I'm just going to pull this all down at once. Label your x's and y's, okay? x1, y1, x2, y2. Take those, substitute them into the distance formula. Keep that distance formula handy. I'm not going to make you memorize it. I think you probably eventually will just because you're going to be using it a lot, but keep that handy so that you can refer back to it. And then use a calculator to compute. There's no need to do things step by step unless you really want to. It's kind of a skill where you have to use a calculator anyway. So in my opinion, you might as well let the calculator do the work for you. Just write it down on your paper, punch the whole thing into your calculator, and let it do the computation for you. All right, go ahead with the practice for 1.7. Good luck.